Sometime in the last 24 months, humanity quietly crossed an invisible boundary. We ran out of things to say, or rather, the machines we built ran out of human words to read. For 15 years, tech giants scraped every blog, book, and social media post ever written to train artificial intelligence. But the reservoir is dry. To keep growing, the machines have started doing something deeply unsettling. They are writing their own textbooks. Most people believe that AI models are still getting smarter because they are consuming more of our thoughts. But that is where everyone is wrong. The internet has been mined to its bedrock. To survive, the AI industry has turned inward, feeding its creations a massive, synthetic diet of their own self-generated data. We have entered the era of the closed loop, where artificial intelligence is grading its own homework, and the consequences of this shift are about to reshape our digital reality. To understand how we got here, we have to look at the economics of information. For years, training an AI was like panning for gold. You scooped up the entire internet, filtered out the dirt, and kept the precious flakes of human intelligence. But human data is messy, dirty, and increasingly expensive. Copyright lawsuits are piling up, and internet users are actively poisoning their public posts to stop scraping bots. This created an existential crisis for tech companies. If you cannot harvest any more data, how do you make your next model twice as smart as the last one? The answer was a silent pivot from data harvesting to data generation. Instead of paying armies of humans to write training essays or label images, developers realized they could use highly specialized AI models to write cleaner, more structured data for other AI models. It is fast, it is cheap, and it bypasses every copyright law on the books. But it also means we are training the future of human technology on information that has never touched a human hand. To see this process in action, look at the sky. Imagine you are building an AI system to spot rare, specialized aircraft in satellite imagery for national security. Under the old way, you would have to wait for a human analyst to scour millions of square miles of satellite photos, hoping to find a handful of rare planes, and then manually draw a box around each one. This is the classic data scarcity bottleneck. A recent research breakthrough called AeroGen solved this by changing the playbook. Instead of searching the real world, researchers used a layout-controlled diffusion model to simply invent the training data. The system generates highly realistic synthetic satellite imagery of airbases, placing rare aircraft in precise, pixel-perfect coordinates. Because the computer generated the image, it already knows exactly where every object is down to the individual pixel. The AI teaches itself by looking at its own dreamscapes. This approach completely bypasses the need for human labor, but it raises a critical question. What happens when the dreams of the machine don't match the chaotic reality of the world? The shift to synthetic data is not just happening in computer vision. It is quietly taking over fields where human privacy is paramount, like medicine and banking. In healthcare, researchers cannot easily share patient files to train diagnostic AIs because of strict privacy laws. The solution has been the creation of tabular synthetic data. The premise is elegant. You take a database of real heart attack patients and use an algorithm to generate a spreadsheet of completely fake patients. These ghost patients have the exact same statistical patterns, the same correlations between blood pressure and heart rate, but they do not actually exist. It sounds like the perfect crime-free technology. But this is where the math gets dangerous. A landmark review of tabular synthetic data revealed a massive flaw. We currently have no standardized, mathematically proven way to guarantee these synthetic spreadsheets do not leak real human identities. If the generative model memorizes too much of its training source, the ghost patient might still carry the digital fingerprint of a very real, very vulnerable human being. To understand the deepest danger of this technology, we have to look at a physical reality. Think about what happens when you make a photocopy of a photocopy. The first copy is clear. But if you take that copy, put it on the glass, and scan it again, you introduce tiny imperfections. Do this 50 times, and the crisp letters bleed into unreadable black smudges. This is the governing dynamic of model collapse. When an AI model is trained on synthetic data generated by an earlier AI, it does not just learn the facts. It learns the subtle errors, the statistical biases, and the slight hallucinations of its predecessor. With each generation of this feedback loop, the model's understanding of the world shrinks. The rare, strange, and beautiful anomalies of human language are flattened out, leaving behind a bland, repetitive average. By the 10th generation, the model is no longer capable of producing coherent thought. It has become a victim of its own digital inbreeding. The threat gets even more complex when training is decentralized. Today, massive AI models are not trained on a single supercomputer. They are trained across vast networks of thousands of individual computers, each processing its own slice of the digital world. This is distributed learning. But what happens if one of those nodes is compromised or begins feeding bad, corrupted synthetic data back into the main system? In computer science, this is known as a Byzantine attack. Just a tiny fraction of poisoned data can cascade through the entire network, corrupting the mathematical updates of the model during training. To survive this, developers have had to implement incredibly complex mathematical filters, like Byzantine resilient stochastic gradient descent. These filters act like digital water treatment systems, using robust mean estimation to identify and discard toxic data updates before they can poison the collective mind of the machine. It is a constant, invisible war waged in the code to keep the data stream pure. Despite these structural dangers, the shift to synthetic data is accelerating because of powerful financial and legal incentives. For the giants of Silicon Valley, human data is a minefield of copyright lawsuits, expensive licensing agreements, and public relations disasters. Synthetic data is a legal escape hatch. You cannot get sued by a novelist for copyright infringement if your model trained on text generated by another machine, even if that machine was originally trained on the novelist's work. This has created a massive, silent gold rush. Tech companies are building proprietary synthetic engines, keeping their generation techniques guarded behind non-disclosure agreements. They are racing to build the largest, cleanest synthetic playgrounds, hoping to train the next generation of models without ever having to pay another human creator. But this corporate race is creating a world where our collective digital tools are losing touch with the physical reality they are designed to serve. As we move deeper into this decade, the boundary between real-world observation and generative hallucination will continue to blur. The internet is already filling up with synthetic text, synthetic images, and synthetic code, meaning even the human data we scrape in the future will be contaminated by the outputs of yesterday's models. We are drifting into an informational echo chamber. If we train our medical systems, our autopilot algorithms, and our financial platforms on data generated by machines rather than physical observation, we risk optimizing our society for a world that does not exist. We risk building a mirror maze where the only thing artificial intelligence can show us is a distorted, degraded reflection of ourselves. The question is no longer how much data we can generate, but whether we will have any real world left to guide us.